we define vectors or show vectors is with with an arrow, because that shows our direction. And so we've got our initial point and our terminal point. Typically, the book, this is the thing about in print, you can do different things than you can when you're writing. It's hard to show bold. In the book, they'll do vectors in bold, but that's kind of hard to do on the board. So typically, they'll use a little arrow on top of it. I'll just do this, maybe not even a full-blown arrow there. But they'll typically, A or B or U, we'll use U some, and specifically in a minute, we'll use U for something else. But anyway, that's what a vector looks like, or a notation for it. And a whole lot easier to give it a single letter than it is to use but you can use the initial and the terminal point to designate that, but we'll a lot of times just use a single letter to designate. Yep. All right. Now, one thing about vectors, as you know, probably know, is let's say I've got the same length and the same direction vector down here, call it B. It's not a real good what I'm trying to do. All right, the same angle, same length, but it's CD here, and let's call that vector B. Well, because vectors are based on magnitude and direction, you got the same magnitude, same length, you got the same direction, going this way, those two vectors are equal. Even though they're in different places, you can move these vectors around as long as they're same angle. You know this, okay. Yeah, those two are exactly the same vector. The position really doesn't matter, and so we'll transfer those around. We'll try to strive for, of course, vectors at the origin, initial point at the origin, is what we'll want to do. Okay. All right. Now to add vectors, I'll do that. Okay. Well, yeah, we'll get to several things. Let's say here's our A, and let's do B here. As far as the geometric interpretation is concerned, you connect them initial point to terminal point, right? For A plus B, we would, here's A, then we put the B, starting it at its terminal point. And on adding, you can switch those around. So the resulting vector then is from the initial point you started with to the terminal point of the B. All right. We mentioned the word scalar. Scalar now, to make the distinction here, vector, magnitude, and direction, whereas a scalar is just typically just the magnitude or so if we multiply by a scalar, what happens? What does that do geometrically speaking? So if I do, here's A, and say then I want to do 2A, multiplied by the scalar, be twice as long. Okay, same magnitude, same direction, but it's going to be twice as long. Half A would be half as long. So that's what a scalar does when you multiply it. What about a negative? Reverses the direction. That's A, then minus A goes in the opposite direction. Same magnitude, but in the opposite direction of what it. All right. Okay. So that means then if we have A minus B, here's A, here's B. A minus B then that would reverse, the minus B would reverse that. would go that way. And so if I put A together with minus B, then I get that, right? One way to do it.